2022 Grade 9 Pascal Math Contest, questions 11 through 20. In the diagram, points P, Q, R, S are at intersections of grid lines in a 6x6 grid. What is the perimeter of the parallelogram PQRS? Well, I guess we have to just manually do this. And this side is 3. You just count 1, 2, 3, and that's 3. This side here, of course, we'll probably use Pythagoras. But the good news is that that side is 4. And therefore, that's a 3, 4, 5 triangle. That's one of the more famous Pythagorean relationships. Most of you, if you're writing math contests, I'm sure you know about that. And therefore, that side's 5 because it's a parallelogram. Therefore, the perimeter would be 3 plus 3 plus 5 plus 5. And that is 16. Therefore, C is the answer to number 11. How many of the integers from 1 to 100 inclusive have at least one digit equal to 6? Okay, so I guess the digit can be either here or here if it's a 2-digit number. From 1 to 100, there's also a 1-digit number, just 6 itself. Okay, and there's any 3 for 1? No, well, there's the only 3-digit number is 100, and 100 doesn't have a 6. Okay, so if the 6 is in this position, that means you can have either 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, and 9, 6. Got it? So how many is that? 10. And if the 6 is in this position, then of course you can have 60, 61, all the way down to 69, and that is also 10. But this is a good question because it touches on the concept of overcounting. And overcounting is one of the most common reasons why people get a question wrong on a math contest. Because notice, you'll say, okay, 10 here, 10 there. That's 20. I'll circle to 20 and move on. But the good news actually in this question is that 20 is not one of the answer choices. So they're being nice. But because if 20 was one of the answer choices, you just selected move on. The reason the answer is not 20 is because we double counted 66. 66 is over here, and it's also in this list. So because 66 was counted twice, we have to subtract 1 from that 20. And when you do, you get 19. So the answer is C. Mayar and Rosie are 90 meters apart. Starting at the same time, they run toward each other. Mayar runs twice as fast as Rosie. How far has Mayar run when they meet? Okay, so here's Mayar, here's Rosie, and they meet somewhere here, right? So 90 is the distance between them. Now speed is equal to distance over time, and therefore time is equal to distance over speed. Now the time for Mayar, when they meet, the amount of time it takes Mayar to go from there to there is the same amount of time it takes for Rosie to go from there to there. So the times are equal. And therefore the distance traveled by Mayar over the speed by Mayar is equal to the distance traveled by Rosie over the speed of Rosie. So therefore, the distance, if this is x, this will be 90 minus x, right? So we'll call this 90 minus x. The speed, Mayar is twice as fast, so we'll call that 2s. This is just s, and this is x. And there you go, that's the equation. This equation, therefore, becomes 90 minus x is equal to x times 2, because the s's cancel, and the 2 just comes up. And therefore, this is 90 is equal to 3x, and therefore x is 30. And therefore, that's 30 and that's 60. How far has Mayar run when they meet? Well, 60. So therefore, the answer to number 13 is D. Dhruv is older than Bev. Bev is older than Elsim. Elsim is younger than Andy. Andy is younger than Bev. Bev is younger than Chow, whatever. Who is the third oldest? Okay, so Dhruv is older than Bev. Bev is older than Elsim. Okay, Elsim is younger than Andy, and Andy is younger than Bev. So we can stick Andy in here. Yeah, because Elsim is younger than Andy, and Andy is younger than Bev. And then Bev is younger than Cow. But we don't know Cow and Dhruv's relationship. So we'll just put Bev here and Cow here. And then they're saying, who's the third oldest? Well, these two are the first and second oldest. The order I don't know. But obviously, that's the third, fourth, and fifth. So third oldest is Bev. And there you go. Number 14 is B. How many of the integers 19, 21, 23, 25, 27 can be expressed as a sum of two prime numbers? First, let's write out all the primes that go up to 27. And of course, you should have these memorized. And now let's see if we can make them make these numbers the sum of two primes. 19, it's pretty easy. 2 plus 17, right? 2 and 17. Okay, that's good. 21, 2 plus 19, I think. That's pretty easy. 23, 2 plus 21, but 21 is not a prime. 19 plus 4, 4 is not a prime. 17 plus 6, 6. 13 plus 10, 11 plus 12, 7 plus 16, 5 plus 18, 3 plus 20, 2 plus 20. Oh, there's no way. So this can't be done. 25, 2 plus 23, that's easy. And then 27. 27, I don't think so. Because 23 and 4, and then a whole conversation, you can't. So I'll let you figure out, the combinations, but there's no way. So it looks like only these three. So therefore the answer is 3, which is A for number 15. Alvin, Bingy, and Cheska play a two-player game that never ends in a tie. In a recent tournament between the three players, a total of 60 games were played, and each of the player played the same number of games. Alvin and Bingy played. Alvin won 20% of the games. When Bingy and Cheska played, Bingy won 60% of the games. When Cheska and Alvin played, Cheska won 40% of the games. How many games did Bingy played? Okay. Well, each of them played the same number of games. So Alvin, Bingy, and Cheska each played 20 games. Now, when Alvin and Bingy played, Alvin won 20% of the games. So Alvin won 4, because 4 is 20% of 20 games. Yeah. Each pair played the same number of games. So since there's 20 games, this pair played 20 games. Yeah, so I think this was misleading here. And of those 20, Alvin won 20%, so that Alvin won 4, and therefore Bingy won 16. Got it? Okay, now let's move on to this pair, which is Bingy and Cheska. Bingy won 60% of these games. 60% of 20 is 12. So Bingy won 12, and that means Cheska won 8. And then finally, Cheska and Alvin. Cheska won 40%, so that means Cheska won 40% of 20, which is 8. And then for Alvin won 12. So they're asking how many games did Bingy win in total? Looks like this 16 and that 12, and that is 28. And therefore, C is the answer to number 16. The integers a, b, and c satisfy the equations a plus 5 is b, 5 plus b is c, and b plus c is a. The value of b is a plus 5 is equal to b, 5 plus b is equal to c, and b plus c is equal to a. Okay, let's see if what we can do. Let's add these. So we get a plus 10 plus b on this side, and this is b plus c. Well, b plus c we can put as a, and that means we have a plus 10 plus b. The a's cancel, so 10 is equal to b. B is equal to negative 10. And I think that's it. They just want me to figure out the value for B. So 17 is C. Five balls numbered 1 through 5 are placed in order on the table. A sequence of steps is performed on the balls. In step 1, the rightmost ball is picked up and put in the middle of the 4 remaining balls. Then, in step 2, the leftmost ball is picked up and put in the middle of the 4 remaining balls. These steps repeat, with the rightmost and leftmost balls alternately picked up and put in the middle of the 4 remaining balls. Immediately after step n, the balls are in the reverse of their original order. Which of the following is a possible value for n? Okay, so keep this in mind. That's an example. So let's do this. Let's do this manually. And let's see what happens. We're not going to obviously do it up to 2,000 and something, but just want to see a pattern. So the first, the start, right? Because they show a start. Yeah, this is the start. Is 1, 2, 3, 4, 5, and this is after step 1. This is after step 2. Okay, I got it. Okay, so let's start. So at the start, it's 1, 2, 3, 4, 5. And then step 1, or after step 1, I guess I can put after here. They basically take this ball and put it in the middle. So they would put it here. So it would be 1, 2, the 5 would be in the middle, and the 3 and 4 would shift over. Got it? Now, this process just keeps repeating, but we alternate rightmost and then leftmost. So now we do it with the 1. We put that 1 in the middle. So the 1 goes in the middle, and the 2 and the 5, they shift over, and the 3 and the 4, I guess, in that case, stay where they are. You got it? Okay, so this was after step 2. The important thing in this question, in my opinion, was to figure out that this was the start, and this was after step 1, this is after step 2. This is not after step 1. You see what I mean? If you make that mistake, like this, you know what I mean? The whole thing gets messed up. You'll get the wrong answer, obviously. So don't make that mistake. Just read the question carefully, and they help you out with that example, that illustration with the balls. Okay, let's just keep going here. Step 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do this quickly. So 5, 1, 2, 3. Wait, hold on. I got to make sure I do it correctly, not just quickly. I got to put the 4 this time. Okay, so 2, 5, 4, 1, 3, right? Then, because I'm alternating, rightmost, leftmost, rightmost, leftmost, like that. Okay, 5, 4, 2, 1, 3, and then now this one, 3, 5, 4, 2, 1. Now, this is the point at which the numbers are exactly reverse of the start, and it happened at the 5th step. Okay, now you say, okay, well, that's great, but does it really help me? Not yet. Still got to keep going. And then you'll see a pattern. So if you keep going, you get 4, 3, 5, 2, 1, right? Because we had to move the 5 in the middle. Now we have to move this 1 in the middle. So it becomes 1, 5, 2, 4, 3. Now I move this 4 in the middle. 4, 3, 1, 5, 2. Now we have to move this 2 in the middle. So 2, 4, 5, 3, 1. Now this one, 3, 1, 2, 4, 5. Well, take a look at it now. Now, this guy is exactly the reverse of that. And that happened at the 10th. If you keep going, you'll find out that every 5 steps, the order is exactly reverse, and therefore it's basically multiples of 5. And among the answer choices, which is a multiple of 5? The only one is E. Miyuki texted a 6-digit integer to Greer. 2 of the digits of the 6-digit integer were 3s. Unfortunately, the two threes that Miyuki texted did not appear, and Greer instead received the 4-digit integer 2022. The number of possible 6-digit integers that Miyuki could have texted is. So we have a 6-digit number, and 2 of these are 3s. So the answer is really just from 6 choose 2. And 6 choose 2 is 6 factorial over 4 minus 2 factorial over 2 factorial. So that's just 6 times 5 over 2, which is 15. Now, if you're not familiar with that choose notation, I'll do it manually. So let's say we label these A, B, C, D, E, F. Now, the 2 3s can be any 2 of those 6 positions. I've labeled those positions A through F. Okay, let's make a list of all the possible positions for the 2 3s, 3 and 3. Well, they could be AB, AC, AD, AE, or AF. Correct? Let's see. What about if we had B as the first 3? You could have BC, BD, BE, or BF, right? You can't, BA is the same as this guy, so we don't want to include it because that would be double counting. You could also have, moving over, CD, CE, CF. You could have DE, DF, and finally, the last one is EF. So count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Exactly what I got with choose notation. So regardless of how you do it, the answer is 15, and that would be choice E. A pizza is cut into 10 pieces. 2 of the pieces are each 1/24 of the whole pizza. 4 are each 1/12. 2 are each 1/8, and 2 are each 1/6. A group of n friends share the pizza by distributing all of these pieces. They do not cut any of the pieces. Each of the n friends receives, in total, an equal fraction of the whole pizza. The sum of the values of n between 2 and 10 inclusive, for which this is not possible, is, okay, well, let's see. When n is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is one of those time-consuming, laborious questions. So when n is 2, that means the sum, 2 people, the sum for each sum has to be a half. If there's 2 people, each person has to get half the pizza. Is that possible? And, well, let's see here. Let's write this out. What are the 2 of the, there's 1/24, right? I'm just going to write the sizes. 1/24, 1/24. There's 2 of those. And there's 4 1/12s. 1/12, 1/12, 1/12, 1/12. There's 2 1/8s. And there's 2 1/6s, right? So can I get a half? And you just have to fiddle around with this, really. And the answer is yes. You can. Basically, I think it's 1/24 plus 1/12 plus 1/12 plus 1/8 plus 1/6. That would be a half, and then the other person would have the exact same slices. Okay, so 2 is good. How about 3? When n is 3, well, I should put it down here. This half. I'm making a table, right? So when n is 3, each person would get a third. Is a third possible? Yeah, it is. One person would get the 2 1/6s. The other person would get all 4 of those 1/12 slices. And then the remaining slices would go to the other guy. It's the 2 times the 1/24, and then 2 times the 1/8. And you can crank out these numbers to see that each of these do indeed add up to 1/3. Okay, great. So yes, there. And you guys get the point. So you just kind of do it like this. So I'll just do the ones that work, and then the ones that don't work, those are the ones you actually have to add up, because those are the ones that's not possible. The ones that work are 4. That's going to be, each person would have a quarter, and it's basically one person gets the both of the 1/24ths plus 2 of the 1/12s, and that it would be a quarter. The other person gets both of the 1/8ths, that'd be a quarter, and then the third person gets 1/12 plus 1/6, and then the fourth one gets 1/12 plus 1/6. Okay, this one's a no, and basically it's just one of those things. You just have to figure out that there's no way that 5 people can get 1/5 each by manipulating these numbers, by adding them in combinations. It's a no for the 7, it's a no for the 8, it's a no for the 9, and it's a no for the 10. For the same reasoning that, for 7, each person would have to get 1/7, and there's no way each person can get 1/7 if there's 7 people by any combination of these numbers. And the same kind of story for 8, 9, and 10. 6 is a yes. You can get 6 people to have 1/6 each. One person gets the 6th, another person gets the 6th, so those are fairly easy. Another person gets the 2 of the 1/12s. The fourth person again gets 2 of the 1/12s. The fifth friend gets 1/24 slice and a 1/8 slice. And the sixth friend, the same thing, 1/24 plus 1/8. Oh, sorry. This should have been here in the 6th category. All this should have been here. You understand. No big deal. Okay, so the ones that didn't work or can't work are 5, 7, 8, 9, 10. So they want you to add those up. So 5 plus 7 plus 8 plus 9 plus 10. 19, 27, 34, 39. 39 is the answer. And that would be choice D for number 20.